Hello and welcome to another video. In this video we're going to be working on a minimum number of pushes to type word to. And in this one you're given a word of lowercase letters. And you can map numbers to letters in any way you want, and you can map as many letters to a number as you want, but every letter has to be mapped to a unique number. And all the numbers you can use are 2 through 9, so these are not used. And your goal is to write out the word with the least number of presses possible, and then if a letter is mapped to a number, the first letter mapped to a number is used when the number is pushed once, and then if it's a second letter you have to push the number twice, if it's a third letter you have to push it 3 times, and so on. So for example, if this is mapped to 9, to push a Z you'd have to go 9999. That would represent the Z. And you're trying to basically map in a way that minimizes the number of pushes. So in this first example you have A, B, C, D, E. So as long as you map A, B, C, D, E to different letters, that's a valid answer, because for all these characters, you're going to have to push it once. But let's say you mapped all of these to a 1, or a 2, sorry. Then A would be 1 push, then this would be 2, then this would be 3, and this would be 4. This would be 5, so that would be bad. So basically the idea is kind of like you're trying to map them to different letters, and then there's some more stuff in here though. And let's say you have this. So the other thing is the order that you have to push these doesn't matter. It's more about how many do I have of each. So I have 4 X's, and then 4 Y's, and 4 Z's. So once again, it doesn't really matter how you map as long as these are all different like numbers. So this is one valid way to do it. Yeah, and that would give you 12, because every single key press is one number. And then we have this. So we have A, B, C, D, E, F, G, H. So that's 8 letters, and then you have I. So you have 9 different letters. And here you only have 8 different numbers. So you can't map everything to a unique letter. So you have the most I's. So you want to make sure that like I is cheap, and everything else is the same. So you can just map 2 letters to one thing. So like in this case, here you map I and H to 9, and then everything else is unique. So A is unique, B is unique, C, D, E, F, G, and then I and H are the same. And then you make sure I is before H, and then I would cost you 1. All of these would cost you 1, but H would cost you 2. So this is the total. So that's kind of the idea, is like if you have these numbers, like let's say we have these available numbers, right? So let's actually make an array instead. So we have these available numbers, not that one, this one. And we don't have these, so these are the ones we have. And so when we're trying to map letters, like if we have a bunch of letters, like let's say we have A's, B's, C's, D's, E's, F, G's, and H's. So as long as you have 8 numbers here, so as long as you have 8 or less letters, you can basically just map one of these letters to one of these uniquely, right? So you could do something like this. You know, this is fine, doesn't really matter. Any way is fine, because then all of these letters will cost 1. And then you don't have to show the other letters, because the other letters don't really matter. They're never pressed, so they could just be mapped anywhere else. It doesn't really matter. But once you have more than 8 letters, like let's say you have 16 letters or something, and let's say we just have a bunch of letter counts. So like one letter has a count. Let's say we have like 1 1, 2 2, 3 3, 4 4, 5 5, 6 6, 7 7, and then maybe we have like 10 and 20. So these are the letter counts of the letter. It doesn't really matter the letter. All we care about is the counts. So if these are the letter counts, we're going to want to make sure that letter 20 costs 1. So maybe we'll map it over here. So whatever letter has a count of 20, we'll put here. Okay, and then 10 also costs 1. So we could put 10 over here. And we could put 7 over here. 7, 6, 6, 5, 5, 4, or sorry, 6, 6, 5. They have to be unique, right? So that way, all of our expensive letters, all of our most expensive letters only cost 1. And now for the second letter, you can just put the one that has 4, 4, 3, 3, 2, 2, 1, 1. So that's how we could do it, right? So all of these are going to cost 2, but we press them less, so those have to cost more, but we want to make sure the ones that cost the most are the cheapest. So you could do that. You could just get the counts of every single letter. And like I said, you don't really care about the letter. You just care about the counts. And you could say like, okay, let me just have these things and let me just go in order, like put the biggest here and then move it down, right? So I could just have like a pointer. I'll put like one here, then one here, then one here, then one here, and so on. Then you'll loop around and do it again, loop around, do it again, loop around, do it again. And then you go back through your numbers and then you can figure out like what's there. But it turns out we don't really even need to put them in places. We can just figure out like what group of 8 they're going to be in, right? So the first group of 8 letters that we put in will take 1 press, right? Because we're going to map like 2, 3, 4, 5, 6, 7, 8, 9, let's say. So those will take 1. Second group of 8 letters will take 2 presses. Third group, 3. And finally, if it's lowercase letters, you have 26, so the last 2 letters will take 4. Assuming you had every single letter in the alphabet. And so all we have to do is we can just get all of these values and just have an index, right? So this will be like the first letter, the second letter, the third, fourth, sixth, fifth, and so on. So we can just take all of our values, sort them in reverse order, and then just for the index, like if this is the first letter, then this is going to be in the first group. If it's the second letter, all we have to do is divide by 8 to figure out what group we're in. So if this is like the 15th letter, we can just divide by 8, and then you do a ceiling divide. So you would get, this is the second group. You would just round up, divide, round up. If this was like the 7th letter, divide by 8, round up, first group. 20th letter, divide by 8, round up, third group, and so on and so on and so on. And then depending on what group you're in, that group is going to just take that amount of presses, right? Because the letter that's first takes 1 press, the letter that's second takes 2, and so on. And the best way to put all your stuff is just say, you know, put the first letter here, second letter, third letter, and so on. And you want to put the expensive letters first. So you want to put all the expensive letters in the first group, and then you want to fill out your groups like this. So that's basically how you do it. So all we really need to do is just get counts of every letter, and then just traverse them backwards and figure out what group they're in, and then that'll tell us how many, like how expensive that is to press, and we just multiply that by how many times that letter occurs. So for example, if this is in group 1, it occurs 20 times, so that will cost 20, and so on, and then we just get a total. Okay, so hopefully that makes sense. So essentially we're just filling out, like imagine you have these things, so this is groups of 8, and we're basically saying we have, not that, we have 4 groups. The last group will only have 2 letters, assuming we have every letter, and we're just going to fill out our letters that way, starting with the biggest count. So this will be like group 1, group 2, group 3, group 4. And so the biggest count will go here, and then so on and so on and so on, until you fill out the first group, then the next one will go here. And we don't need to actually fill these in, we can just divide by 8 to figure out what group it's in. Okay, so let's code that. Okay, so let's code this thing. So first thing we're going to have is an int array counts. Then we are going to loop through our word. And we're going to increment every character. So word character at I. And then we want, so like A will have some number, some ASCII value, let's say like 80. We don't want 80, we want it to be 0. So we can subtract the ASCII value of A to make A 80, and then, or A is 0, and then B 1, and so on. Then we can sort it. So this will be in increasing order, so we're going to go through it backwards. So we'll say 25. And then we will have a result. So the group that it's in, so 25 is group 1 basically, and then 25 is 1, or index. 25 is index 1, 24 is index 2, and so on. So we need that. So we can say result plus equals ceiling of the index, which is So it's going to be like I think 25 minus I plus 1. Is that correct? So if I is 25, this will be 1. If I is 24, it will be 2. If I is 23, yeah, I think that's correct. Okay, so we want this guy, this index, divided by 8. But if we do this in Java, this is an integer divide, so this will be 0. So I think we can do that to make it a decimal divide. And then you do a decimal divide, round up, and then multiply by counts of I. Okay. And if it's 0, this will just be 0, so it won't matter. Yeah, so. Or you could break early, either way. Alright. Okay, there we go. Oh, yeah. So this is going to be n log n. So actually, so the nice thing about this is, and the nice thing about using hash maps of letters in general, is you only have 26 letters, right? So like lowercase English letters is only 26. So this is length 26, which means this is constant time, constant space. So we have to go through the word, which is ov(n), because that might be long. But the sort is basically constant time because it's 26 length, and this is its 20 constant time as well. So I think it's just gonna be like this. Yeah. Curious what it says. I mean, it might copy mine, so probably will. Okay. I wonder if I just write some random stuff. Okay. And yeah, and I did do this in Python, and I made it kind of funny, so I'll share that really quick. The beauty of Python, I guess. So you can literally make a counter, get the values, reverse the values, and do the equation in one line. Imagine reading this thing, but yeah, I thought it was kind of funny. So yeah, it's going to be all for this one. Hopefully you liked it. If you did, please like the video and subscribe to the channel. So I'll see you in the next one. Thanks for watching.